So we've covered the intersection of a line and a plane. What I've got here for you is a couple of questions relating to it. I want you to read the questions, pause the video, have a crack at them, and then come back and check your answers with what I'm going to show you here. Here you go. So it's just two questions for you relating to this topic. First one's about finding the point of intersection between a plane and a line. Second one is about a point of intersection and an angle. Now, these are two very common ways that the questions are done, so it's good that we need to know these skills. So pause the video and have a ping at them now. So the first question, point of intersection between the plane given by 3x plus 2y minus z is 5 and this line here. Remember, to solve it, first thing we do is rearrange our equation of a line to be a parametric form. Then we substitute into the equation of the plane. Then we solve that for the parameter value. And then we substitute back in to the parametric equation of the line to get the x, y, and z part of the coordinate. So what I've got to do is set all three of these equal to lambda, and this is going to be my parameter value here. So if I were to do that, I could rearrange the equation of the line to look like x equals 1 plus 2 lambda, y equals negative 1 minus lambda, and z, quite simply, equals 3 lambda. There's no number on the top with it, so that doesn't shift across and give me a number here. Now that I've got that, stick it into the equation of the plane. So what I'd end up with is 3 bracket 1 plus 2 lambda plus 2 bracket negative 1 minus lambda minus the z, so minus 3 lambda, and that all equals 5. So now that I've got all of that, what I have to do is multiply out the bracket and then simplify everything, so get all the lambdas together, all the numbers together, and solve and find the value for lambda for which it works. So if I multiply out the bracket, I get 3 plus 6 lambda minus 2 minus 2 lambda minus 3 lambda equals 5. Sort this left hand side, and what I end up getting is lambda plus 1 equals 5. So lambda is equal to 4. Now I take it and put it back into these equations here to find my values for x, y, and z at the point of intersection. So I know that x is going to equal 1 plus 2 times 4, so that's 9. Y is going to equal negative 1 minus 4, so that's negative 5. And z is going to equal 3/4, so it's going to be 12. So what I can say is fine. That means my point of intersection, my POI, is given by 9, negative 5, 12. So there you go, finding the point of intersection of that line and that plane gives me that coordinate there. Now the second question, again, was finding a point of intersection between a plane and a line, but it then also wanted the angle as an extra part here. So split it up into your two steps. Let's do the point first. So my point, and again we follow the exact same set of steps as we did before. First, rearrange this into parametric form. So let's let it equal to the parameter lambda again. So what I'm then able to say is x is equal to minus 1 plus 2 lambda. Y is just equal to 3 lambda. And z is equal to 3 plus 6 lambda. Now I take all of these and substitute them into the equation of the plane here. So I'm going to get 10 bracket negative 1 plus 2 lambda plus 2 times the 3 lambda there minus 11 times the 3 plus 6 lambda equals minus 3. Multiply out of the brackets, then simplify it. I get minus 10 plus 20 lambda plus 6 lambda minus 33 minus 11 sixes, so minus 66 lambda equals negative 3. Gather all the lambdas together and then all the numbers, so 20 plus 6 is 26. Take away 66, that gives me minus 40 lambda. Then got minus 10 minus 33 minus 43 lambda equals negative 3. Shift the numbers across, I get negative 40 lambda is equal to 40, so lambda is equal to negative 1. So now, same set of steps as before, substitute into here to get my x, my y and my z part of my coordinate. So I get x is equal to negative 1 minus 2, so it's negative 3. My y is quite simply equal to negative 3, so 3 times lambda, 3 times negative 1. And my z is given by 3 minus 6, so that's at minus 3. So what I can say then is therefore my point of intersection, my POI, is given by negative 3, negative 3, negative 3. So that there's the point in the three-dimensional space where that line and that plane intersect one another. What I've then got to do is calculate the angle. Now in order to do that, what we have to do is remember the formula that we had before, wherein we were able to say that sine theta, where theta is the angle between the plane and the line, equals the magnitude of A dot U over magnitude of A, magnitude of U. Now in this, remember, A and U represent the normal to the plane and the direction of our line. So what I'm going to do is let A represent my normal. So in this case, A is going to be given by 10 to negative 11. And I'm going to let U be the direction vector of my line. That's going to be given by 2, 3, 6. I can get both of these just by inspecting the equations. I'm then going to do my A dot U. So my A dot U, that's going to equal 10 times 2, so 20, plus 2 3's, so plus 6. I've then got plus negative 11 times 6, so that's going to give me minus 66. So that's going to equal negative 40. My magnitude of A, what that's going to give me is the square root of 10 squared plus 2 squared plus my negative 11 all squared. If I was to do all of that, 10 squared plus 2 squared plus my negative 11 squared, that would end up giving me the square root of 225, which is quite nice because that's just 15. If I then did the same thing, but this time for U, so magnitude of U, I'd end up getting the square root of 2 squared plus 3 squared plus 6 squared. Calculating all of those out, what I'd end up getting is the square root of 49, which is equal to 7. So we end up with quite nice values, to be honest with you. So I can substitute them in here, and because it's the magnitude, ignore the negative with a 40. So what that then means is that it's equal to 40 over 7 times 15. So rearranging it, I know that theta is inverse sine, so sine minus 1 of 40 over 7 15s. 7 15s is 105. And at that point, just plug it in your calculator and you get your solution. So if I plugged it in a calculator, I get 22.39 and so on. So my angle is then 22.4 degrees. So there you go. That's me got my solution there. Working through the steps, it's not difficult. It is the same set of steps every single time when it comes to this sort of question. Now, it's very common to get asked it in this manner, to get asked these properties. It can be taken a bit further in a slightly more abstract sense and in a slightly more applicable question if you're looking at some way of using it, but it still breaks down to these skills, these sets of steps, and in essence actually some basic algebra. I mean, calculating the point of intersection, once you've substituted in, that's first year algebra right there. Even the substitution is first year algebra. Rearranging it, changing the subject of the formula, second year algebra, maybe third year at a push. Sine theta equals that. You know, inverse sine, that's S1, trigonometry right there. So all of it does break down to skills that we know. We just have to remember them and be able to use them effectively and accurately in the questions when it comes down to using the skills that we need.